And welcome to this section on algebra and functions, and in this series of videos we're going to be focusing on quadratics, quadratic expressions and quadratic equations. Now this is a big old beast, there's a lot to get through here, and the principles and the techniques we'll be looking at here just underpin absolutely everything that goes on. This is kind of the number of different situations where quadratic equations or expressions appear, and you have to be able to deal with them in a range of situations. It just goes on and on and on. So you really do need to be absolutely clear on the principles and what's going on with these. So what we're going to be doing is just recapping your skills of factorising quadratics from GCSE, and then the second bullet point there, just kind of extending that a little bit further into kind of slightly more complex situations. And then we'll go back and have a look again at GCSE content essentially, which is how you solve quadratic equations, 3 different ways of doing that. And then we'll extend beyond GCSE and start looking a little bit more about kind of the number of roots an equation has and how that links to something called the discriminant, and also how that relates to the curve, or let's say if you plotted it as a graph. And then finally, the last thing we're going to do is look at how we can use completed square form of a quadratic expression to understand where the minimum or maximum point on a curve is located. Okay, so off we go. First thing we're going to do then in this video is just recap your factorising skills. Now again, this is essentially GCSE, so all I'm going to do is just run through some quick examples, a few hints and tips along the way, and then it's just a case of you spending some time practicing and making sure those skills are well embedded, and you've kind of looked at them again and you've built on them from your GCSE. So here we go. 4 examples for us to deal with, all of them with slightly different issues, and we'll talk through those as we go through. So the first one, here we go. 9x squared y minus 21xy cubed. Anytime you're presented with anything and you think, okay, what can I do with this? You're thinking, can we factorise? And I'm going to look for a common factor. So what I'm looking for is there something in here that's also in here that's common to both? And clearly we can see we've got 3 will go into 9 and 21. We've got x's in here, and we've got y's in there as well. So my common factor in this particular case is going to be 3xy. Now I'm going to ask myself the question, which my cursor appears, oh, there it is what am I going to put in here such that when I do 3xy times by that, I get back to 9x squared y. So clearly I'm going to need 3, because 3 times 3 is 9. I'm going to need an x, so x times x is x squared, and the y is already there, so I've got 3x. And in my second term, I've got a 21 here, so I'm going to need a 7 to go in there. I don't need any extra x's, and now I'm going to need a y squared. So there we go. And there's my factorised expression. And just to make sure, it does say factorise completely, so we've got to make sure there's nothing else that I can take out. So I'm now looking at what's in my bracket and say, well, is there anything common to both? Clearly the answer to that is no, so I've factorised it as far as I can go. So that kind of the algebraic and bracket version of simplifying a fraction as far as it can go. In the next example, we're looking for a factor. There's no common factor. So this is one that hopefully you'll recognise from GCSE, where I've got to do it with a pair of double brackets. And I always like to set that structure up first. So there's my brackets. I know the x times x is going to give me an x squared. So now we're looking for 2 numbers, and hopefully you can remember from GCSE, we've got 2 numbers that multiply to make 30. And at the same time, those 2 numbers have got to add to make minus 7. And a quick bit of thought, hopefully we can all see that that's going to be 3 and 10 multiplied to make 30. I'm going to be able to make 7 out of those. Now I've got to think carefully about my signs, because my 30 is a minus, means I'm going to need 1 positive, 1 negative, and I've just got to think which round that needs to be in order to make the minus 7. And hopefully you realise that we're going to have x plus 3 bracket x minus 10. On to the next one, again, slightly different structure. Again, I'm going to say, well, have I got a common factor? And I have. My common factor is going to be a 3, so I'm going to take that out. And now what I've got is a quadratic expression, and no common factors in there. But what I've got is something similar to part B, except it's the middle term, that x term, that's missing. And again, if you remember back to GCSE, what we're looking for now is something essentially that's going to require us to multiply to make minus 9, but the 2 numbers have got to add to make 0, so that middle term disappears, and that means we're going to be using a technique called difference of 2 squares. And hopefully you remember that all that means is we've got to have the same in the two brackets, but I've got one's positive, one's negative, because now what's going to happen is the 3 times the minus 3 gives me the minus 9. I'm going to get plus 6x coming from those two. I'm going to get minus 6x coming from those two, so they kind of cancel out. And so we've got the expression we need. Called difference of two squares because clearly this thing here, 4x squared, is a square number. It's 2x times by 2x. 9 is a square number. It's 3 times 3. And difference because we've got the minus sign in there. And finally, we've got x squared plus 11x, and I'll put this one at the end because it sometimes seems to confuse people, even though it's really straightforward and a lot more straightforward than B and C. It's the same structure as quadratic, but this time instead of the x term that's missing, it's the number on the end that's missing. And the simplest thing to do with this is say, well, again, we go back to, does it have a common factor? Clearly the answer is yes, there's x in both bits. So take out the x, and that just factorizes as x plus 11. And on we go. Okay, all of these ones, again, we're going to take our skills a little bit further. Look at some slightly more complicated examples. So here we go. First one, 5x squared minus 40x plus 35. The difference with this one is we've now got an x squared coefficient, which is the 5. But again, I would always advise you have a look first. Is there anything we can take out to make our lives a little bit simpler? In this case, clearly, we can pull a 5 out the front of the bracket. And as soon as we do that, that all of a sudden becomes a whole lot more simple because we can see inside that bracket now, that's just going to do simple bit of factorising. That's x minus 7, x minus 1. So it's just exactly the same as before, but we just multiplied the whole thing by 5. So you've got that 5 out the front. Okay, this next example, we've got a similar issue in that we've got an x squared coefficient, but this time when we have a look at it, we'll realise that there isn't a common factor, so we can't take the number out the front the same as we did before. So we're going to have to think about how we're going to deal with that when we do our factorising. And again, I'm always a big fan of setting up that structure, those two brackets, and the only way we're going to be able to get 2x squared is by having 2x and x at the front of my two brackets. The next job now is just to play around with factors of 42, and the more you do these, the more you'll become comfortable and you'll start to spot things. But initially, I'm just going to chuck some numbers in and see what happens. So let's say 42 is 6 times 7. So let's put those in, and let's say I choose to put them in that way around. Now, with experience, you'll start to realise kind of what's going to work and what's not. In this particular instance, I know straight away that that's not going to work. The reason is because I can take a factor of 2 out of there, which would mean I'd be able to have a 2 at the front. And if I could do that, if this was going to work, it would mean all of these terms would have a factor of 2, and they don't. So I know straight away, because I can take a factor of 2 out of there, this 2 and a 6, that's not going to work in the bracket that way around. So I say, I know that's not going to work, so let's have a look at what happens if I just swap those around. Now I'm looking at, say I've got my 42, am I able to make the minus 5x? Well, if I have a look at what's going to come from the middle terms, I've got 12x coming from there, I've got 7x coming from there, so this is looking fairly good. 12x and 7x, I can make 5x. So all I've got to do now is think about the signs I'm going to put in. I need it to be minus 5x, which means 12 has got to be the minus. It's got to be plus 7x, that's going to be minus 5x. So now I can just put in the signs. There we go, so I've got 2x plus 7, x minus 6, and there it is factorised. And I'd say it is just a case of putting in numbers, seeing what happens and what works. If you try something that doesn't work, okay, just cross it out, try something else. But like I say, the more you do them, the more you'll be able to kind of spot them and get a sense of what numbers are going to work. On we go. Now technically this one's not a quadratic, it's a cubic because we've now got a power 3. But again, that first principle, look for any common factors. Can we take something out? Clearly I've got an x there in both. So I can take that out, and now we've broken it down into our x times by a quadratic. And again, this is one where I've got the middle term missing. I've got an x squared there, I've got a square number there. So I'm thinking dots, difference of 2 squares. So that's going to be x plus 4, x minus 4. And there it is. Later on in the course, you'll look in a little bit more detail about how to deal with factorising cubic equations and more complex cubic equations or expressions than that. But like I say, those will be appearing later on. We're just going to focus on the quadratics now. And then finally part D. Okay, this one looks a lot more horrible. But we can use the same principles we've just been doing, and I'm going to set up the structure there, and this time it's going to look like that because I've got 2x times x, that's going to give me x squared. I've got y times y, that's going to give me the y squared. And from here I've got 2x times by y, that's going to give me an xy term. That's going to give me an xy term. So the structure's the same. All I've got to do now is figure out what numbers or how many lots of y I'm going to do there and there. So again, I'm looking at this, I'm thinking, okay, they've got to multiply to make 15, so I'm thinking 3 and 5. So let's chuck in 3 and 5. Is that going to work? Well, I'm going to get 3 lots of xy from there. I'm going to get 10 from there. So can I make minus 7? Clearly I can, just by putting signs in the right way round. There we go. So I've got minus 10xy from there, and positive 3xy from there. That gives me the minus 7xy that I need. And there we go. Done and sorted.